Hello, fifth grade mathematicians and fifth grade scientists. Today we're going to be talking about revolving and rotating of the planets. We know that Earth revolves around the sun, and that takes 365 and 1/4 a day every year. And when we rotate and experience a full day on Earth, it takes 24 hours. But here on your screen, you're seeing Jupiter. Jupiter only takes 9 8/10 Earth hours to make one full rotation. So imagine our day, if we were on Jupiter, it'd only be 9 8/10 hours. That wouldn't be very long. Wow, it would be crazy to think about that. So my math question is, how many Earth hours are there in 46 days in Jupiter? So I'm going to be doing Jupiter for 46 days, so I should be thinking about multiplication. I'm not going to add 9 8/10 46 times. That would be insane. So this is the problem that I have presented to me. So let's think about that problem. I'm going to completely ignore my decimal point to start. I'm going to pretend like it's not there, and I'm going to be doing 98 times 46. We are familiar with that, and if we're not, let's use this as a brief review to do that. I'm going to start with my ones place, right, and do 6. So 6 times 8 is 48. And then 6 times 9 is 54, plus 4 is 58. So now I'm done with my ones place. I'm going to move on to my tens place, and when I do that, right away I'm going to put a 0, right? I even told you to ignore the 6. And then we're going to go to our 4 in the tens place. 4 times 8 is 32. I'm going to get rid of this 4 from previous, and I'm going to put my new 3. 9 times 4 is 36, and 36 plus 3 is 39. Now I have my problem I must add. And of course I'm running out of room here, so when I add them up, I'm just going to do it over here on the side. 8, 10, 15, so I'm getting 4,508. But now it's time to think. Let's go back to our decimal point right here. I'm going to rewrite the problem so it was easier for you to see. How many spots are behind a decimal point here in my multiplication problem? I only see 1. I'm going to underline it even to help me. 1 spot behind the decimal point. So when I go to write my decimal point in my final answer right down here, I'm going to make sure 1 spot is in the decimal point. So my final answer for the Jupiter days problem is 450 and 8/10 Earth hours. So that would be my label there. So you want to count how many spots are behind the decimal point and then make sure that goes in your final answer. Let's do another one together. Here we have a similar problem with Mercury. There's Mercury. It looks kind of like the moon, but it is in fact Mercury. Mercury has a day on their planet that lasts 58 6/10 Earth days. So think about that. Oh my goodness, their one day is equal to this many Earth days? Whoa. So how many Earth days are there in 14 days on Mercury? So I'm going to multiply it because I want to talk about 14 Mercury days. So there's my problem. The first thing I'm going to do, right, boys and girls, is ignore that decimal point. It's not there. So I'm going to do 586 times 14. And let me work through that. You can pause your video, and I think you should work through it too because it's been a little bit since we've been doing multiplication, so it's always good to go back and review that. I'm going to go into my tenths place here. I'm going to cross off all my other stuff. 6 times 1, 8 times 1, and 5. Ooh, that was an easy one. I'm going to add it up. Okay. So now I have my final answer of 8,204, but wait, how many spots were behind the decimal? That 6 was the only one behind the decimal, so there's going to be only 1 spot behind the decimal, so I'm going to add that decimal point in there. And now my final answer is 820 and 4/10 Earth days. Imagine that. 820 20 and 4/10 Earth days for only 14 of their days. It's pretty insane. So now I'm going to give you one to do completely on your own to make sure you understand the concept. Here's the problem that I want you to do. Remember to ignore the decimal point at first, and then at the end, figure out how many spots are behind the decimal point and tag that on in the end. I'm going to solve it now, but you can solve it by yourself and check it with me after you unpause the video. So now I go back and I decide how many were behind my decimal point, and it was 2 spots this time. So I'm going to make sure 2 numbers are behind my decimal point. So 1, 2. So that means here. Sometimes I even actually draw little humps like this, like 1, 2. That way I know that that is where my decimal point goes. So my answer would be 148 and 88 hundredths. So you could always go back to your first answer and say, okay, does it make sense if my answer was just 14,888? That's a rather big number considering what I was multiplying by. So yes, that would be wrong. Did I put my decimal point in? Now it makes sense that my number would be lower. And of course, there would be numbers in the decimal point. So that is how you solve a multiplication problem using decimals, and make sure you're just always counting those decimals up.